All right, guys, hello, whoever came here today. I do plan to hold another class on Thursday, just to try to catch up with the material. And here, a few more are joining. We are unhindered today by other classes, as nobody is in his right mind or her right mind holds classes on reading day and beyond the semester, right? So I presume I'm right. So then you are all mine. I don't know. I presume more than 10 and less than 50 estimation. All right, so guys, where have we left off? Of course, I haven't seen it. Would I need to see an exam, guys? If you know the material, you don't need, right? It's not in your eyes. You all watch those deadly sports videos with Van Damme, right? Or were you too young for that, right? So you don't need to see. Remember how Van Damme defeats his enemy without sight. So what have we learned last time, guys? We learned how to figure out summation of this form, which means, please, it means in expanded form, simply as k goes from 1 to n, I just add c. You understand? So if k is 1, I add c. If k is 2, I add c. If k is 3, I add c all the way until I get to n. I just add the c's, and what do I get? I get n times c. That's the easiest sum we have learned. So for instance, if I add up, let's say k is equal 1, 2, 3, and I add the number 5, please tell me what's the number. I want a very fast response rate. What number am I getting? Not 5 cubed, 5 multiplied by 3. Yes, it's 5 plus 5 plus 5 3 times. So this is 15 is what I'll get. Good. It's 5 plus 5 plus 5. Good. Beautiful. Then we learned how to add up numbers like this, guys. So what is 1 plus 2 plus 3 all the way to plus 10? This is represented by the sum k equal 1 to 10, for instance, of k. And what's the sum in this situation? Please remind me. Thank you, Safa, precisely. It's 55. So the answer here is 55. Good. Now, why is that? Why is that the answer? Because, well, look at it. If I take 1 plus 2 plus 3 all the way to plus 10, and I say the sum is s, I can write s as 10 plus 9 plus 8 all the way to plus 1. What do I get? I get that 2s is equal to 11 plus 11 plus 11 plus 11. How many times? 10 times. So that's equal to 11 multiplied by 10. And so s is equal to 11 times 10 divided by 2. Yes? You see, guys, if you understand the idea, the entire thing can be done in a second. If you don't understand the idea, the entire thing is meaningless. What's next? What's next is we have figured out, guys, how to find the summation of the squares. So k1 to n of k squared, right? And that summation is the summation for 1 squared plus 2 squared plus 3 squared plus n squared. This happens to be the same as n plus 1 times 2n plus 1 divided by 6. Yes? Now, why is that the situation? I don't know. I don't like to waste my time on it, but I guess let's see if you remember one idea by which you can easily establish this formula. So guys, when I took such exams, I never remember those formulas. So when I had a question where I had to calculate Riemann sums, I did it spontaneously there. When I needed, I just figured out the formula while doing the exam. Yes, and that's what you should be able to do. You should be able to do that in a few minutes. Like it should take you 1 to 2 minutes at the most to be able to derive this formula. Now, what is the idea from calculus that we had, guys? So first of all, I can write the summation, not the summation I'm interested in, but this interesting, this strange looking sum. K plus 1 cubed minus k cubed. Now, the reason I do that, guys, is that this summation, even though minus k cubed, did I say plus k cubed? Yeah, minus, good. So this summation, even though it looks scarier than the k squared, it's actually a much simpler summation. What is that equal to, guys? Do you see what's happening? So what's happening here? If I were to expand it in red, if I were to expand it, what is actually happening? If I plug in 1, I get 2 cubed minus 1 cubed. Do you agree? Plus 3 cubed if I plug 2 minus 2 cubed. And so on and so forth until I reach n plus 1 cubed minus n cubed. You agree? This summation is just a shorthand for that. Now, what is happening here? Do you see that I am adding a bunch of cubes and I'm subtracting a bunch of cubes? Do you agree? Now, I'm subtracting everything except for n plus 1 cubed. That's the only thing that is not subtracted, right? Because 2 cubed will be canceled later on by 2 cubed. You agree? Basically, the sum that is subtracting, I'm subtracting 1 cubed all the way to plus n cubed. And I'm adding 2 cubed all the way to n plus 1 cubed. Can you hear me, guys? Do you see it? Yes? 2 cubed all the way to n plus 1 cubed is what I add. 1 cubed all the way to n cubed is what I subtract. What remains? N plus 1 cubed remains, and minus 1 cubed remains. Do you agree? Everything else is common and is cancelled. So this is equal, on the one hand, this is equal to n plus 1 cubed minus 1 cubed. On the other hand, guys, I can say that this summation is, if I expand it, it's what? It's k cubed plus 3k squared plus 3k plus 1 minus k cubed, if I expand it. And in this form, I can cross away k cubed. Yes? And what remains, guys, do you see that what remains in this formula? Look at it carefully. What remains is 3, the summation k1 to n of k squared. This is what I am interested in. I don't know what the sum is. I want to know what it's equal to. I just got myself an equation here, yes? And then I have plus 3 summation k1 to n of k plus summation k equal 1 to n of 1. Everybody understands how I distribute the sigma sign to all the terms, do you? Write y for yes if you understood, or n for no if you did not, because otherwise I'm just talking to myself in a hot room. Completely understood, guys, because it's just a sum, it's just a notation. What are we doing? We are just summing things. right? And I can decide to sum likes first, and then other likes second, and other likes third, right? So I'm summing terms, those terms first with those second, etc. Now, these summations I know, guys. Tell me, please, what is this equal to? What is this equal to, please? So the answer is, guys, we just solved the summation. You have to, you see, you have to solve this again and again until it's you don't guess, you don't memorize. If you try to memorize, the answer is 3n n plus 1 divided by 2. The answer here is what? What's the answer for the second green that I know how to solve? Very good. The answer is n. So do you see what we have here, guys? We have 3 times something that I want to find, plus 2 numbers I know equal to a number that I know. So what I can do from there, I can just solve. You agree? I'm not going to go through that. That's now algebra. Move things around, simplify, and you get the formula. Good. So all you have to know is you have to be comfortable with the idea. Here I just go through the explanations. Here I expand it. Here I solve it, simplify it, blah, blah, blah. Here is what I get once I simplify it. Good. You should think about figuring the formula for k cubed, and the result you will get if you do figure it out. Basically that 1 cubed plus 2 cubed plus 3 cubed, let's say plus 5 cubed, guys. What would that be? That would be 5 times 6 divided by 2 all of it squared. Okay, that would be the summation. So the general formula for k equal 1 to n of k cubed is just n times n plus 1 divided by 2 squared. So if you remember the first formula, the second formula is not very hard to recall. But the one for k squared, I personally am always unsure if I remember it correctly. Now, I suppose we had reached our saturation of today's attendance. I will take a photograph, and you understand, guys, what this thing is for. I mean, I gauge by this attendance how many of you care about this class, or am I just the only one who cares about what you grade, what you get for a grade? So that in case, let's say, people do not do well, I will consider giving 10 points extra credit. But if I see no effort, I do not give that 10 extra credit points at all. Good? Funny enough, and just as I mentioned it, it's as if there is telepathy. There is one person that is worried about the extra credit joins. But what do you know? I guess there is this connection that I have with my students, as they say. All right, guys, and here we go and talk about the area under the curve. Now, imagine waking one night, one sleepless night, and suddenly thinking, what is the area below the curve y equals f of x over the interval from a to b? Yes? Yes, you wake up and that's the only thing that matters to you. Now, why would that be? Well, let me give you at least several ideas, guys. So here in probability, something very interesting is, for instance, just this problem if you study anything related to medicine or anything related to epidemiology or disease propagation and all that stuff. So, for instance, imagine that you want to know the prevalence of a certain illness within the general population. So you presume that there is you know, there is a disease rampant in the general population, and you want to know how rampant. So what you do is, let's say you gather 1,000 individuals, and you were able to find that 50 of them have the illness. How do you extrapolate to the population? How many people within the general population have that illness? So as it turns out, guys, the answer to this problem ends up being the integral of this curve. You see f of x, this is the integral. This is the area under this curve. It's written in notation as integral from a to b f of x dx. I will in a moment explain why that's the notation for finding area under the curve. So the answer to the probability of this disease, of how prevalent it is in the population, is this. And then by studying this area, as you draw over here, I can conclude, for instance, that the prevalence of this disease, 99%, I can be certain with 99% confidence that the disease is anywhere between 3% of the population are ill to 7% of the population are ill. You understand? I am with 99% confident that the disease is between 3% to 7% prevalent in the population. If I take a bigger sample, I can increase my certainty. You follow? Which, by the way, has not been done neither here nor in Germany. And instead, what do? Is, yes, but that's, you know, because this, you know, a combination, yes? Yes? Mathematics is, guys, not just mathematics, not just calculation, but actually having a brain and actually thinking is important, I hope, right? Even though, of course, doing mathematics does not imply that you have a brain, as I verified with myself many, many times, right? Just be careful, right? But so I think it's possibly something that might increase the probability that you have a brain, which is itself, probability is then itself area under the curve. Right? So again, we're back to being interested in area under the curve. Another thing, guys, is physics, right? Now, how many of you are reading my notes outside of class or doing preparations outside of class? I presume not nearly enough. And why? Because you conserve your energy. Now, what is conservation of energy if not integral under the curve? You understand that when you say energy is not created or destroyed, this is a mathematical concept, right? And a mathematical concept that momentum is neither created nor destroyed, or energy is not created or destroyed. This is just a property that we know as the fundamental theorem of calculus, which, if I shall be so lucky, I will teach you before the semester is over. Good? So area under the curve is tremendously important because so many important ideas are linked with it. Oh, I almost revealed it, guys. So now I guess, what do you do with calculus? With calculus, when we studied curves, do you remember what we did, guys? A curve is complicated, but you can take the simplest instance of a curve, that is a straight line, and you can describe other curves using a bunch of straight lines. So basically, I can think of any curve as a sequence, a chain of line segments. And that's the philosophy of calculus. You understand? I understand other curves by studying a chain of line segments. Now, if my goal is to study area, what is my pixel? What is that simplest object I will pick to try to describe area? What do you think? Rectangle, and I hope it's not because you just saw the rectangle below in my notes here. But indeed, guys, the area of a rectangle is width times height. Now, why is it width times height? Because at its very basic, you are just counting how many tiles you can stack in that rectangle. So if the width is 2 and height is 4, then you can stack 8 squares. 8 unit squares, right? So you just count how many of them. 2 plus 2 plus 2 plus 2. 2 added to itself 4 times, or 2 multiplied by 4. You see? So in general, it's height times width. And those are my pixels. So how would I study area under the curve, guys? Well, I will do the same thing. You see, what I will do is I will take the curve and I will try to fit in underneath the curve very, very thin rectangles. Hair thin, yes? Rectangles, and because they are so thin, they're much thinner than in this picture, they will fit very neatly underneath the curve. Now, what will be the height of a rectangle at point X? It's going to be f of x. And because it's very thin, its thickness is dx. You see, this is dx. So f of x times dx represents a particular rectangle that is essentially standing on top of the point X. Are you with me? And then what do you have here? This just means, this is this symbol, guys. Can you guess what this means? I wrote it over here. So that means sum. It just means add up the areas of rectangles, and those rectangles are placed between point A to point B. Do you understand? So this is as simple as that. What is this integral? It's just add up areas of rectangles. Sum. Yes? You see why the symbol is very useful, guys. The symbol tells you precisely what you have to do. If you never saw it, it reminds you of the process that you should carry to achieve to figure out the area. And we're going to figure it out right away. Good? And here is, again, another picture of it, guys. Here, you see that I have placed lots of rectangles, and the representative rectangle at point X is of height f of x and width dx. So that's f of x dx is just the area of one representative rectangle. And this tells me add them all up, all the rectangles from point A to point B. So this integral sign is sum. Good. Now, how can you actually carry that process, guys? Well, obviously, we can carry that by taking the limit. We're just going to build, let's say, maybe 1,000,000 rectangles or 1,000,000,000 rectangles, or in general, n rectangles, and take n to infinity. You agree? N, where n is presumed to be a large number. So how are we going to build it, guys? So let's first decide to use the right-hand approximation. Right-hand approximation means that I will first partition the interval from A to B into n sub-intervals, right? So the width over here, the width of each sub-interval is b minus a divided by n. Is it clear so far, right? B minus a divided by n. So for example, if I partition into 100 intervals, it would be b minus a divided by 100. That is the width of every single interval. But we want n to be huge. So we would just say b minus a over n, where n is a big number, whatever number you give me, yes? So, and then I will erect the altitude at the points x1, x2, x3, that are the rightmost points of each block. So you live in New York, or I presume you do, and you understand the idea of blocks, right? So what you do is you go up the block, and at the end of the block, you build the height of your skyscraper. Yes, at the right edge of the block. So then what are the construction instructions? What are the instructions? So you start at the point A, and from the point A, you are going to walk to your construction site, to your workspace. Good. So how do I get to x1? Well, the direction is this: start at A and displace one block. In other words, it's a plus 1 times b minus a over n. Do you agree? At x2, if you start from A, you have to displace 2 blocks. So it's 2 times delta xn, yes? Which is 2 times b minus a over n plus a. And onwards, right? And in general, guys, the kth block, in other words, how do I specify any kth point? To get to this kth point for any k, I just have to start at A and move k blocks. I hope you understand abstraction here, guys. K is just whatever number of blocks. If k is 3, then move 3 blocks. If k is 4, move 4 blocks. So the general point of construction is A plus k times delta xn, which is A plus k b minus a over n. Good? So the approximation is then going to be f. F is the altitude at xk, the altitude at the point xk, times the width of the skyscraper. So this is the cave skyscraper, the skyscraper on the KF block times the width of the skyscraper. You understand this formula, guys? If you understand this formula, everything else should be very simple. So then we define that the integral from a to b of f of x dx is limit as n goes to infinity. Why n goes to infinity is because we want the skyscrapers to be many and we want them to be thin. So if n goes to infinity, it means that their thickness is decreasing because we divide b minus a, we divide by n. So the thickness is decreasing and we have more of them. And that should produce a better fit of rectangles below the curve. Yes, you can see that, correct, guys? And this is that limit, guys. This is what it means. I need to figure out what is f at a plus k times b minus a over n multiplied by b minus a over n, and then add it up. So let's try to calculate the integral from 0 to 2 of x dx. Okay, so first of all, guys, unfortunately, the picture is already displayed. So you understand, if you realize what somebody is trying to figure out, they're trying to figure out the area under the curve. This is the curve. At x, it's f of x is x. So the curve is y equals x. So in other words, someone is trying to figure out the area of a triangle, which I can do geometrically. I don't even need to do any calculus. You agree the area is width times height divided by 2. So that is because it's half of a square in this case. So it's 2 times 2 divided by 2. So the answer should be 2. Correct, guys? The answer is 2. Now, of course, we are learning it out of order, but you also remember that there is a shortcut, right? So this should be something like x squared times 1/2 evaluated from 0 to 2, which will be, if you plug in 2 here, it's 4 over 2, so the answer is 2. So with the shortcut, you can see that the integral should yield 2, but why is the shortcut working? That's what we try to understand. Why is this shortcut doing anything? How does it work? When does it work? Yes? So here, guys, how do we establish this using this function? How do we verify that Riemann sums work? Let's do it using the long-winded way, using Riemann sums. So what do I do, guys? First of all, I'm going to divide 0 to 2 into n intervals. So I get that the width of the interval is 2 divided by n. Do you agree? 2 over n. 2 minus 0 divided by n. This is the width of my block if I have created n blocks. Now I can walk from this point 0 to the point 2, and I go 0 plus k times delta xn, and that is k times 2 over n. Do you understand that, guys? So this tells me the location of the point at which I will create my altitude. So then what do I do with this point? Let me see, guys, if you tell me. This point, k times 2 over n, if you follow, what do I do with that point, please? It's the point on the x-axis. At that point, what do I do? This, right? I take the stick to create a skyscraper. What do I do mathematically? How do I create that altitude? Put it into f of x. Thank you. And what is f of x in this case, guys? What is f of x in this case? F of x that I'm integrating is x, which means that if I put it into that function, the function is identity. It's not doing anything. It just spits back the same output, yes? So the altitude is this, guys. F of xk, it's f of k times 2 over n, which is just k times 2 over n in our particular case because the function is f of x equal to x. Are you with me? And then what? And then I apply the Riemann sum. It's just the altitude multiplied by the width, which is k times 2 over n times the width 2 over n. And I sum it from k1 to n. And look what happens, guys. I can factor out a common term, 2 over n squared, you see? And I get a very familiar summation. Summation of k from where k is going from 1 to n. You recognize it? So I get that summation that I wanted to understand just a moment before. And so what does that equal to? The summation is just n times n plus 1 over 2. And you see this formula, guys? I now take n to infinity because the idea is the number of blocks I should have should be large and should be very large. So limit as n goes to infinity, what does it reduce to? You see, guys? It reduces to take the limit. What survives? What's the only important? Think in the box, I call it. So it's 2 squared times n squared on the numerator, 2 over n squared on the denominator. So what survives is 2 squared over 2, and the result is 2. I hope you remember from early on, guys, how to take limits at infinity. That the only thing that matters are the leading powers in the numerator and the leading powers with their coefficients, of course, at the denominator. And the limit is simply 2. Just as expected, the limit is 2. Now, if you understood it, guys, let's play this game, right? I want you, you know that in some languages you read left to right, but in other languages you read right to left. Yes? I want you to construct this particular structure, this skyline, for this integral. I want you to construct the integral from 0 to x dx. But this time I want you to move from 2, and x1 is here, and erect altitude at x1, and x2 is here, and erect altitude of x2. You understand, like this. I want you to begin locomoting from the point 2 to the point 0. And I want you to give me a formula for the xk and the formula for the Riemann sum, please. Guys, have you ever given anyone directions? So here they say, how do you get to the point x1? So, oh, start at 2 and then displace by 1 times 2 over n. Do you agree? That would be x1. Very good, very good. Sandra, amazing. Very good, right? You just walk backwards, right? So in general, what is xk? That's 2 minus k 2 over n. You agree? So then what's the area? The area is just f of this number times the width. Do you understand, guys? This is the width, this is the height. Confirm if you understood, guys. Width, height. You see what the 2 over n is? 2 minus 0 is the full interval, divided by n is this small dx, and then you have the height. Yes? Beautiful. And so the function is not doing anything. You see, the function is it's leaving the x as is. You see, f of x equal to x means don't touch the input. So what we have is now we have 2 minus k times 2 over n times 2 over n. And so now I add this whole thing up. So it's k1 to n, 2 minus k2 over n times 2 over n. I can carry the addition by distributing the 2 over n. So it would be summation k equal 1 to n 4 over n minus 2 over n squared. And again, we see the summation that is related to k. Yeah? Now, guys, what is the first term equal to? What is this equal to? If I add up from k1 to n, 4 divided by n, what am I going to get? Very good, 4. Yes, very exactly. It should be 4. You agree, guys? Because I add 4 over n plus 4 over n plus 4 over n until I reach n. So I added n times. So the first part should be 4. What is the second sum, please? So it's minus 2 over n squared times what, please? Very good. Times n plus 1 divided by 2. And in the limit, guys, what happens? If I push a limit to infinity, I get 4 minus, what do I get here? I get 2 squared divided by 2. So altogether, I still have 2, just like before. Now, your turn, guys. Tell me, what is the integral from 0 to 1 of x squared? You have 5 minutes. If Safa, and another thing, you can use naturally shortcuts, right? I want you to give me a formula when you finish Riemann sum, because this thing is clearly, I mean, you can say this is 1/3 x cubed by our shortcut from 0 to 1, and that would be 1/3. That's of course the nice and quick way to do that, but we will try to understand why the shortcut even works. I want you to understand why this thing, what this thing is by Riemann sums today. All right, Alexandra, very nice. And so guys, so let's do it now together. What's the idea? So we can begin constructing it from 0. Here we'll have x1, and at x1 we erect altitude. So we move like this. Yes? So what does it mean? It means that xk is equal to 0 plus 1 minus 0 divided by n times k, which is simply k times 1 over n. Agreed? Which means, and now I am going to calculate f of xk times 1 over n times the width. And that is what? That is xk squared times 1 over n, which is k1 to n of k divided by n squared times 1 over n. Agreed? And so what do we get? We can factor out 1 over n cubed. So it's 1 over n cubed summation from 1 to n of k squared, which we know as 1 over n cubed n plus 1 to n plus 1 divided by 6, which if you push to infinity, what do you get? You get on the bottom, you get 6, because it's 6n cubed, and on the top it's 2n cubed. So it's 2 over 6, which is 1/3. So this original answer, of course, was correct. You follow? Okay, so this is to get very comfortable with this idea. You should practice those questions. Here is another question, guys, from 1 to 4. There are plenty of them that I did from 0 to 1, right? So there are plenty of those questions that I set up for you to try to figure out, and some of them are very tedious. Okay. Now let's try to understand some properties of the integral. So the integral, you see, look at it. If a function is continuous, you see here I zoomed in on one of those rectangles, and here is that rectangle. Now if the function is continuous, within a short interval segment, all the lengths are essentially the same. You agree that there's very little difference between any of the lengths within this interval if it's sufficiently small. I mean, here I exaggerated and I created some difference that you can see. But because the function is continuous, you agree that this point that approaches another point, it's the altitudes are getting the same everywhere. So that means that that for very, very small intervals, it would always look to you like a perfect rectangle. Now that allows us to conclude the following, guys: that I can figure out the integral by partitioning into n parts and using xk star. In other words, using either left or right or any point in between, and that would work. You understand? I can use, I don't have to use the right hand point. I could use anything. I mean, sometimes if I want to do Riemann sum and actually carry the limit, some points are more convenient. Some choice, some regularity is more convenient, but that regularity is not required. Do you see why? Because if I take the right point or the left point, altitude is essentially the same. And here I suggest to use the left-hand limit. You see? So here for some integral, I want to be expressed as the left-hand limit. Now that means that for the first interval, for kf interval, I want to displace one less. Right? For the first, I don't want to go here. I want to go 0 distance. For this, I want to go, for the second interval, I want to go 1 distance. and so on, right? So I can write it as either a plus k minus 1, b minus a over n, or if I prefer, I can simply set k equal to 0 all the way to n minus 1 and write the same formula I used to write before. I prefer this notation. You understand what? Because I'm just reading what it says. It means for first one, just don't displace anywhere, just put 0 here. And then for the last one, displace n minus 1 steps to arrive here. If you displace n steps, you will get to the very last point. Is this clear what I just said? Write Y if you understood what I just said, guys, please. Thank you. Again, guys, very simple visual. Just where are you going? If you're using the left-hand point, then how do I find altitude for the second point, for the second interval? I displace only one block because at this age, right? So for the second, I displace one block. For the third, I displace 2 blocks. For the kth, I displace k minus 1 blocks. And instead of using k minus 1 as it looks uglier, I still want to use k, but I'm going to set it from 0 to n minus 1. This means the left-hand sum. And they are all the same. And I could use the left-hand sum, guys. I could actually use the left-hand sum or the right-hand sum. I mean, I can decide to pick whichever location. I can walk from B towards A or from A towards B. It doesn't matter. Right, this is just a description of how I pick the points at which I will construct my elevation. And here you have the midpoint and whatnot. And here, guys, exercises A through D, you have to look at this limit and tell me what integral does it correspond to? What would that look like in integral form, please? So what is it for A? So let's look at A, guys. Look, what's happening here? You have to just look at it and see, do you see where the integral is getting, guys? You see, you have to recognize the function integrated and which one? You see, you can see that 2 over n and 2 over n over here. That means that's our width. Now, where do we begin from? It looks like we have a plus, so it means that we are moving to a bigger number. So it looks like the small number here is 3. And what's the biggest number? Well, let's look at it. If k is equal to n, then it's 3 plus 2. So the biggest number is 5. Confirm if you understood, write Y so far if you understood how I did it. It's a matter of reading it, guys. Nothing more. I mean, what is happening here, just look at this. It's somebody is adding up areas of rectangles. Where does he begin working? He begins working from the point 3 and displaces to the right. How far will this person go to the right? Well, 3 plus 2. Because if k is n, it would be 3 plus 2. So what is the function that's being integrated, please? Which function are we integrating? Very good. Do you see that function over here, guys? This is the point swallowed squared plus 1. So it's x squared plus 1 dx. Yes? Now, very quickly, tell me what's the answer to be. All right. Now we can see what function we are going to integrate. Yes, guys? So where do we begin? So first of all, it looks like we have an upward ascent from the point -1. Do you see it over here? So -1 plus k. Yeah, so -1 plus, well, be careful, not plus 4, -1. And the last point, -1 plus 4, which would be 3. So it's from -1 to 3. Yes? Of x squared plus 5x plus 7 dx. Agreed? You see what's happening, guys? You just -1 plus the displacement, full displacement. If I move through all the blocks, how far will I get? I will get to -1 plus 4. And we have this expression. Now I want you to do C. Thank you, Alexandra. And from where to where? What's the initial value to last value? Very good, Sophia. Look at it, set k equal to 0, it will be from 1. Set k equal to n, it will be 1 plus 1, which is 2. So 1 to 2. You see, set k is 0, that means don't walk anywhere, that's your initial point. Set k equal to n, that's your destination. That's if you move through all the blocks, through all the train stations. So this is integral from 1 to 2 of root x plus e to the x dx. Very good. What is this? Yes. So this is the integral from -1 to 0 of simply e to the power of x. Do you agree? Dx. Notice, guys, that with the shortcut, we can solve all those. If we have it in Riemann form, those limits can be easily solved. Here I just go on. Okay. Now we can talk about definite integrals, guys. Once we create the definite integral like Pygmalion created Galatea, it takes a life of its own. In other words, we created this integral to find the area under the curve, but it can do other things too. It has its own consciousness. And what do I mean by that? Well, let's look at it, guys. The function, this summation, this means f of x times dx would work even if the f function is negative. Do you agree? I mean, in calculating area, I assume that the function f is positive, but that should work regardless. Aha. Frankenstein. Frankenstein's monster, maybe. So here we have, right, guys? Here we have a curve that dips below the x-axis. Some places is negative. So over here, it would be fx, which is negative number, times positive dx, which means the red region here will generate negative areas of rectangles. Do you agree? To generate negative areas of rectangles. So altogether, what will we get, guys? We will get a minus b plus c. Do you agree? The integral would be a minus b plus c. Now, what other properties of the integral are very obvious? So we have all those properties, guys, that we have to understand and learn, 1 through 6. So the integral of c from a to b, just the integral of a constant. So that's just one giant rectangle. So obviously it's c times b minus a. It's the altitude multiplied by the width. Good. Next is, guys, the integral of a sum is the sum of integrals for the very simple reason is that, look at it, this integral itself is just add up things, right? So you're adding things up. So you can, if informally, you can think of f of x plus g of x times dx. I can multiply by the x and I have f of x dx plus g of x dx. And then the summation becomes separate sums. Formally, this is clear because if you represent it as a Riemann sum, here you have an actual summation without the limit. And the actual summation can be broken into two separate summations by grouping together f's and grouping together g's. Clear? So the integral of a sum is the sum of the integrals for a very natural reason. Next, guys, is what is going to be next? Next is factoring a constant. It's the same as foiling something out of the sum. The reason the constant can be moved out is pretty much the same that you can factor a constant out of parentheses, right? Out of a summation. That's property 3. You agree, guys? if I have C times summation is the same as C multiplied by each individual summand. And that can be, again, if you can translate it to a limit if you need to, right? The integral can be translated to a limit. And then you can see that it's really nothing more than a fancy sum. You understand that? So this symbol is nothing more than just add things together. Very not fancy, not complicated. Now, guys, would you tell me, please, what is the integral from a number to the number itself of the function f of x dx, please? What would that equal to? Come on, guys, faster. The answer is, of course, 0, because this is just an area that has no width, if you think of it geometrically. But if you think about it formally, this integral just means this limit. So I begin from this point, and I displace by k multiplied by top point minus bottom point, which in this case is 0 divided by n. And that's the width. So what am I adding up? I'm adding up lots of f of a's multiplied by 0. In other words, I'm just adding up a lot of zeros. Yes? And then, guys, we are getting closer and closer to remarkable properties. Can you figure out, and that's the least obvious one, guys, if I have integral ab as opposed to integral ba of the same function. What's the relationship between them? Well, inverse or opposite are a bit not clear. So more precisely, what is the relationship between them? Opposite. That's correct. Why are they opposite, guys? Why are they opposite? Let's try to understand why the answer is opposite. So let's consider how to relate BA of fx to AB. Let's see what happens, guys. Look at it. The integral from BA is this, right? Its limit as n goes to infinity by the, doesn't matter where B is, if B is bigger than A or not, the limit will just do this. It will take this point here and add to it k times top point minus bottom point over n, and then a minus b, right? So look at it. It's a minus b here rather than b minus a. You see, formally this is what happens. It's f of should be f of box. I mean, I made a mistake here. It should be f of a box. Triangle minus box. Triangle minus box. Should be box here. Yes. You just take this point and add to it k difference here, right? So what happens, guys, if I rearrange it? Look at it. I can make it b minus a. If I make it b minus a, I have to factor a negative. You see, a minus b is minus b minus a. This is where the negative went. And here, I take the negative out. It's b minus k over b minus a over n. So what is this, guys? Without the negative, this is the integral where I walk from b towards a backwards. Do you see that? Here I'm just walking backwards. So instead of starting with a, instead of using this direction, I'm using that direction which I showed you today. Confirm if you understood why this is minus a to b. It follows right away from Riemann sum. Do you see what I'm saying, right? Instead of going this way, I just end up going this way for the other integral. That's amazing if you understand it, guys. That's what we need. Good, so we have the situation. Now property 6. Property 6, guys, is, so again, you see the difference, right? So integral from a to b, I can reverse the bounds of integration and make it negative. doesn't matter which is larger, A or B, both integrals make sense, at least formally, right? So if you see guys, if you ask me, for instance, to calculate, let's calculate something like this, right? So let's calculate 2 to 0. Let me actually do it on a separate page, just to ham the point in. Look guys, if I calculate the integral from 2 to 0 of x squared dx, yes? Let's suppose I want to do this integral. What am I doing in terms of Riemann sum? So in terms of Riemann sum, I take it to be a limit as n goes to infinity of the summation k equal 1 to n. The function is squared. Where do I begin? I begin at 2. And I add 0 minus 2 over n and multiply by k. And here I take 0 minus 2 over n. That's what formally the creature that we have brought to life, that's what it's doing. You understand? It doesn't care it just takes the bottom point plus k times top minus bottom divided by n, squares it 0 minus 2n. Yes? What am I going to get? I'm going to get limit as n goes to infinity. And here I have summation k1 to n, 2 minus k times 2 over n. You see, I just made it minus k over n. And here I have minus, and here I have 2 over n. Do you agree? Squared. And then, of course, I can either change, I understand what it means and change it, or I just deal with it directly. So this is limit as n goes to infinity minus and then the summation can be factored out. So that would be 4 minus this times that times 2, so minus 8 over n times k plus k squared 2 over n squared multiplied by 2 over n. Yes? And then what do we get? We get limit as n goes to infinity of, if you just multiply this times that, so it would be 4 times 2 is 8. Let's add it up. It will be 8 minus 8 over n times 2 over n times n plus 1 divided by 2. And then there's a minus outside here, right? And then what do we have here with the k squared? It's going to be 2 over n, so plus 2 over n cubed. K squared is n plus 1, 2n plus 1 divided by 6. And when I push the limit, what am I going to get? I'm going to get minus, here I have 8, minus 8, this is also 8, plus 2 to the power of 4 divided by 6. And the answer is simply minus 2 cubed divided by 3, which is what we would have been expecting, right? So the answer is minus 2 cubed over 3. We would have expected this answer because by the shortcut, what is this? This is simply 1/3 x cubed from 2 to 0, which is minus 1/3 2 cubed. Yes? Good. Now the next property, guys, is that if I have integral from a to b, f of x dx, then the integral is equal to integral from a to c of this function plus c to b of this function. Now, it's somewhat intuitive that that should be true if c is between a and b. Do you agree? Because that means the area of this plus the area of that, right? So just a to c, you can move to an intermediate point c, and then from c to b. The thing is, this is absolutely true even if c is below a or above b. C does not have to be in between. This formula is always true. You can always visit an intermediate point c and go back to b, and the integral from a to b is the integral from a to c plus the integral from c to b. Yes? Now, I hope you understand more or less why that's intuitive if c is between a and b. I give you a geometric picture. You understand it? If c is between a and b, why that's true, guys? Right, yes. Good. Now, what happens if c is below a? Then let's look at this, guys. If c is below a, the integral from a to c plus the integral from c to b is equal to minus the integral from c to a plus the integral from and I can break c to b. C to b I can break into integral from c to a and then from a to b. Do you agree? So the second I can break into integral from c to a and then from a to b. So these two cancel each other out and I'm left with ab. If you see what I'm doing, guys. So I'm saying that even if c is below a, this property still holds, that the sum of integrals from a to c plus c to b will be the integral from a to b. And that's because if c is below a, I can first reverse this to be minus c to a. And then the integral from c to b, I can break from c to a and then from a to b because of a similar picture. And then I get my property. And then, of course, if c is bigger than both of them, the integral from a to c plus c to b, I can break the integral from a to c into integral a to b plus integral b to c, because now b is in between. I can use, you see, I'm using the fact that b is in between. I break it from a to b and then from b to c. Yes, guys, you are not getting a stroke from my c to a to b, c to c, right? You follow me, yes? So a to c plus c to b. And then what do we have? You have a to b, b to c, and then c to b. C to b I can write as minus b to c. And again, I get integral from a to b. Good? Now, guys, we are moving to the next step. I want you to realize that if you understand what you're doing, you don't have to use the procedure that we're doing. You can just figure out, you see, guys, that's the idea of strategy and intention. If you understand what someone's intentions are, you can accomplish that same task in an entirely different way. That's my hint for the next exercise. You see, guys, I want you to figure out what is this as fast as you possibly can. A. What's the answer to A? As fast as you possibly can. I will only wait 2 minutes. All right, guys, let me help you. What are we trying to find? Socratic approach, guys. What are we trying to find? Very easy, right? The easiest possible way to answer it. Area. Very good, Jeffrey. We're trying to find area. Of what are we finding area? Let's look over here, guys. If I set y equals to root of 1 minus x squared, it's a portion of a unit circle. Do you see why, guys? If y is equal to root of 1 minus x squared, that looks awfully familiar. That's just the unit circle. So y squared equal to 1 minus x squared. So x squared plus y squared is 1. And I integrate from where? From 0 to 1. So I'm integrating on the, you see, this is positive. You see, this root is positive, which means I'm in the upper hemisphere. And because I'm between 0 and 1, I'm actually taking a quarter of it. So the answer must be 1/4 pi. One quarter pi is my answer right away. Do you see that, guys? 1/4 because look at it, it's not the full circle, it's the positive part of the circle. So it means that I'm only seeing the upper hemisphere. And then because the integral is from 0 to 1, I'm actually only looking into the right quarter, right upper quarter. That's where it is. So the area of the full circle is pi. And if you take a quarter of it, you get a quarter of a pi. Yes, everyone gets me? Brilliant. Then you can, of course, figure out what this thing is without too many calculations, guys. Can you tell me what this is without calculations? You can do it with calculations, naturally, but some of them are much easier without, right? So this was easiest to do without any calculations. So here, guys, it's from 0 to 3. So I can break it into two integrals, integral of x and integral of -1. So here is what I did. Yes? So it's the first area is 3 times 3. So it's 9. 9 divided by 2. And the area here is -3. So it's 9 over 2 minus 3, and it's 3 over 2. Yes? Now, please figure out what is this integral C, please. Tell me what's the integral for C is. All right, let's do it together. Guys, let's break it apart into several regions. You ready? So first region, what is this? This is the upper hemisphere of a circle, or the upper part of the circle from -3 to 3. It's half the circle of radius 3, which means its area is 9 pi over 2. Integral from -3 to 3 of x is 0. You see why? Because here we have a negative region, here we have positive region, they cancel each other out, so it's 0. And the last one is just area is, width is of a rectangle is 6, height is 2, so the area is 12. So the answer is 9 pi over 2 plus 12. Here is another question, guys. Are you ready? If it is known that the integral from 0 to 10 of f of x dx is 17, and the integral from 0 to 8 of f of x dx is 12, what's the value from 8 to 10, please? What is this integral? Very good. The answer is obviously 5. You just subtract, right? It's this thing is oh, you get it. So this was, I think, on the review for integration, guys, from the exam. I'm not sure if you watched it. So what happens here is those are some comparison properties. So if the function is always positive over the interval from a to b, then of course adding up the rectangles will produce a positive sum, yes? So that's a pretty obvious property. The other one is if f of x is bigger than g of x over the interval from a b, then the integral of f will be bigger than the integral of g. Which means that if f is between little m and big M, the area of f of x will be always bigger than little m times b minus a. Do you agree, why? This is just the lowest possible f I can take and multiply it by the width. And here I multiply by the biggest possible value that f can take, or that f is less than. So we have this estimate. Everyone's clear on the last statement? Now, here we can use property 3 to estimate the integral from 0, 1 of e to the minus x squared. So for example, over the interval 0 to 1, the smallest value e to the minus x squared can be is e to the minus 1. Yes? E to the minus 1 squared, e to the minus x squared is always less than 1. So what we have is that this integral is anywhere between e to the minus 1 times 1 minus 0 and 1 times 1 minus 0. So this integral is between e to the minus 1 and 1. Now, here, guys, I'm going to skip it for today. It's pretty, I hope it's interesting. It shows you other properties that you can use integral for to understand relationships, relationship between circumference and area of a circle. All those things are explained here. Volumes, yes, and other things of that sort. I will skip it. Integration shortcuts, guys, we're learning before. Right, this is the shortcut. Yes, so we have solved those questions before. But here, guys, could you, just to check, could you calculate the integral from minus 1 to 1 of 1 over x squared? What do you think this one is? So what's the integral, guys, of minus 1 to 1 of 1 over x squared? All right, guys, what's going on? Are you trying Riemann sums or something? Guys, if you had to solve very quickly this integral, if you had to solve the integral, let's say from 1 to 2 of x squared dx, right? You would have probably done this, I mean, this, right? From 1 to 2. Yes? And then that would have been 8 divided by 3 minus 1/3, which would be 7/3, correct? Good. Again, I am a bit pushing something. I'm again pushing something here. All right, so here people would have tried. You see, you're just so unused to it that I'm not sure I can even surprise you. Because we just do it so late. But you see, a lot of people, they get comfortable and they love the shortcuts and they're very happy. And what do? They just take antiderivative of 1 over x squared. It's minus x to the minus 1. And then they evaluate minus x to the minus 1 from minus 1 to 1. And they get minus 2. Now, is this right? Well, obviously it's not. Look at it, guys. Do you see that the area, if anything, looks like it should be positive? Or maybe they are right in some sense, but definitely not because of intelligent thought. It's just they apply the shortcut without understanding when it does and when it does not work. And in this case, it does not work. So how do you figure out when the shortcut works and when it does not work? That's the question, guys. And now my question to you is, do you want to continue today, or you had enough of me and you want to leave? And bear in mind, guys, Thursday is, I presume, the last day for us to have a lecture. You know, you can read, of course, the notes and watch the videos and who knows what else. But let me know very quickly if you would like to end the lecture here, or you want to have more math shoved into your head. Okay. All right, so got to go. I was very unsurprised by that, guys. Watch the video, prepare for next class. We will try to push as much as possible, but you know where to find my videos, correct? You know where to see my notes. So I personally never like watching videos on math. I prefer to read. But if you prefer to watch videos, you can watch those videos that I have. You can read my notes. Be ready with this information, and hopefully we carry it through. Final tomorrow? Ah, not my final, so that doesn't matter, Nicole. Yes, you watch it twice as fast, huh? That's true. You see, guys, you can watch twice or 1.5 the speed. Yeah, I never actually watched a video like this, but yes. Wonderful. Watch those videos, guys. Think about it. Solve those questions. Be ready for your exam. You're very lucky. Your exam is, I believe, on the 25th. I will check again. I think I sent you an email with the link, correct? It should be on the 25th from 6 to 8. Yes, I actually never checked it, but I believe you. I sent the link. Good. Now, guys, if anybody wants to remain for a what when where question, although I'm tired, I might do a what when where question. It's obligatory. Yes. All right, guys. What would you like? I'm stopping the video.